This video will discuss question 28. What should be the gain mu? And then 8 options are given for this gain. In this question, when we are referring to the gain mu, we're talking about the gain of these two identical amplifiers in this output stage. The caption here contains very useful information about the circuit's operation in the quiescent point. And the main bit of information we're going to use is this output resistance. The output resistance of this output stage is 2 ohms. We could also say that this output resistance is the output resistance of the upper transistor, so that's this QP, so the output resistance of the P transistor, in parallel with the output resistance of the NMOS transistor. But how would we compute these output resistances? We can compute the output resistance of this P branch by only looking at the upper half of the circuit. We can now create a small signal equivalent circuit of this subcircuit. This is what the small signal equivalent circuit would look like. The transistor has been replaced by this voltage controlled current source, and we have omitted a parallel resistance to this because we haven't been given any parameters regarding the channel length modulation. So we assume that the channel length modulation can be neglected in this circuit. To compute the output resistance, we should be able to compute the input current as a result of this test voltage, and that input current would be Ix. If we perform simple nodal analysis at this node, that would give us that Ix is equal to minus GMP times VSG. And since the source voltage of this PMOS transistor is ground, that'll mean that we will have GMP times 0 minus mu Vx, because the input voltage here is amplified by a factor of mu by this amplifier. So that will give us GMP times mu Vx. And to now compute the output resistance of the P branch, we just have to divide the test source voltage by the input current as a result of that voltage. And that'll give us Vx over Vx mu GMP, and that is 1 over mu GMP. And in a completely analogous way, we can find that the output resistance of the NMOS branch is 1 over mu GMN. So the output resistance of this output stage is 1 over mu GMP in parallel with 1 over mu GMN. Now the output resistance can now be rewritten to 1 over mu GMN plus GMP. The next step you should take is finding out what these GMN and GMP are. GMN can be found by taking 2 times the drain source current, the large signal drain source current, which in this case is IQ, is given in the caption, over the overdrive voltage. The overdrive voltage of Qn and Qp are the same, and no current will pass through the load. So in other words, both Qp and Qn will see the same large signal current through their channels. We can also say that this is equal to GMP. And if we fill this out numerically, you will find that it is equal to 6.66 milliamps per volt. And now the final step is to remember that that output resistance should be equal to 2 ohms. So if we now fill in these two parameters, that means that 2 ohms has to be equal to 1 over mu 6.66 plus 6.66 times 10 to the power of -3. And if we rewrite this to find mu, that'll give you that mu is equal to 37.5.